So with this question, in 2019, this part A snuck back into the test. So this was very similar to question 5, I think it was, that you had. You might not have this if you're doing this question in future years, but show AB is non-singular. So singular matrices have a determinant of 0. So all we've got to do is work out the determinant of AB. So that's going to be K. And then you would cross out the row and column k's in and do the determinant of what's left. So it's going to be 1 times 0 minus 4 times 0. Okay, and then we take the 8. So, okay, and you would do the same thing. You cross out the row and column the 8 is in and do the determinant of what's left. So that's times 0. Then we go along and it's going to be plus 1. So remembering the pattern, if we use the top row, it is positive, negative, positive. Cross out the row and columns, it'll be 1 times 4 minus 1. So that equals 3, not equal to 0. Therefore, oh, should probably put determinant AB at the front. Therefore, AB is non-singular. Remembering you should always write a conclusion with a show that. Okay, now part B. So we want to find the inverse of AB, and it's going to be in terms of K. This is one way they're going to force you to do this, show that you can find an inverse and you can't use your calculator. So the way this was done in the book was firstly to find the matrix of minors. So what does that mean? Well, it means for the K, you cross out the row and column, rather similarly to when we found the determinant here. Cross out the row and column and do the determinant of what's left and write that in the place where K was. Then we go along. So we'll do the same with the 8, cross out the row and column, do the determinant of what's left. Then we do the same with the 1, and we already know that's going to be 3. And now we're going to carry on and do the same with the next row. So we go like that, we're going to be a bit careful, so that's going to be negative 4. Okay, then you're going to do the same with the middle row, and so on. You don't have to show the costing out, you can just imagine it in your head. Okay, when you've done that, now it doesn't matter which order you do the next two things in. What the mark scheme does is it then does the matrix of cofactors, and now this is where you change the signs in the appropriate places on the matrix. So the pattern is positive, negative, positive. Now this doesn't mean make that element positive or negative. It means if you've got a negative, change the sign. So 0, 0, the 3 stays as it is. Now the negative 4 becomes negative, negative 4, so that's positive. And that becomes negative 4k plus 8. Right, so I'm just putting this matrix of signs kind of on top of my matrix and changing where necessary. And then we need to transpose the matrix. Now in your book it did these two steps the other way around. Obviously it doesn't matter because this is a symmetrical pattern. This is also known as the adjugate or adjoint matrix, just out of interest. So then what this means is this diagonal stays the same, and then you kind of reflect in the diagonal. So that's going to stay the same. And then the 0 and the 4 are going to swap places. The 3 and the negative 1, and the 1 and 8 minus 4k. So we're just going to transpose everything along that diagonal. And then the final step is you've got to do 1 over the determinant in front of the matrix. We'll multiply everything by 1 over the determinant, and that will give us the inverse. Now we found in part A the determinant was 3, so it's just going to be 1 over 3, and then just write the matrix that we've got here. I would recommend that you don't bother multiplying in this 1 over the determinant, just leave it in front, and that's how you'll see it in mark schemes. Okay, so that's our A inverse matrix in terms of K. Now it wants us to find the inverse of B. Now we might probably want to be able to use, we don't know anything about B, we know AB and we know A, so we're going to have to use what we've got to find out the inverse of B. Now this you can quote without proof, but we can also show it as well. Okay, so you should know that the inverse of AB is the inverse of B times the inverse of A. Okay, you don't have to prove this every time, but to prove it to yourself, you know the fact that AB times its inverse must be identity. So here I can pre-multiply both sides by inverse of A. Okay. Now this side I can actually, as long as I don't change the order, I can pair up the inverse of A with A instead of having the A with B. Obviously anything times the identity is itself. Now these is the identity matrix. So I've got BA equals A to minus 1. I do the same thing again now. I pre-multiply both sides with the inverse of B. Okay, that's going to be the identity, and so therefore I've proved it. Okay, so that's what the inverse of AB is. What do I want? Well, I want to get to this. I want to get to inverse of B. So what do I need to do with that? So I want to get with the A minus 1. So if I multiply both sides by A, remember with matrix multiplication, you have to keep the order the same. So the A goes on the end of this side. It's got to go after the AB negative 1 on that side. So I'm going to get inverse of B is AB inverse times A. All I need to do now is put in what I've got. So that's going to be a third times my inverse matrix. And then I'm going to multiply by A, which was up here. So, okay. Okay, I will again just leave third, and then let's multiply these two together. So remember, we start our first row times first column. So conveniently, there's lots of zeros. Okay, then we're going to do, if I go along now, I could do first row, second column, which is going to give me, there's a 0 again, I've got negative 4, and then negative 1 times 4, which is going to give me negative 8 unless I've got it. Oh, copied a sign for my inverse matrix wrong there. Getting a bit confused there, it's going to be the wrong answer. Okay, so I've got 4 and negative 4, so that gives me 0. Right, and then we just go along, so now I'm going to do first row, last column, which will give me the element in the first row, last column. So 0 plus 8 minus 8, again, that's going to be 0. And then I go, now I want the element here, so that's second row, first column. So second row times the first column, so that's going to be 0, 0, negative 3. Now I'm in the middle, so I want second row, second column. That's negative 1, plus 4. Conveniently, you can see all the signs filling out, and I'll go along. So second row, final column. And now I'm on the last row and each of the columns in turn. And you should find most conveniently all the k's cancel out. So then that's now a third times everything, and I would now multiply it because everything divides by a third. Okay, and there you can see, so that's my answer to matrix B.